H point group. Order for this point group is 4n and existing symmetry elements are Cn, n, C2 which are perpendicular to this Cn, sigma h and n sigma v will present. If n is even, I will be present. So let us take D2H point group. Order for this point group is 8 and symmetry elements EC2, 2 C2s, 2 sigma V's, sigma H and S2 is nothing but I. So the example is ethylene. So in ethylene, the C2 which is passing through 2 carbon atoms is principal axis of symmetry. And one C2 is possible through in between the pi bond and another C2 is possible through center of gravity. So this through this C2 the sigma is considered as sigma V and the molecular plane also considered as sigma V and this C2 is perpendicular to the principal axis, right? So the plane which is passing through this C2 can be considered as sigma H and if we pass a straight line through the center of gravity it is reaching two similar atoms. So I will be present. And the next example is diborane. Next, D3H point group. For D3H point group, order is 2n. Possible symmetry elements E, C31, C32, 3 C2s, 3 sigma V's, sigma H and remaining 2 S3 will present. All trigonal planar molecules will come under D3H point group. So let us take the example BX3 where BX3 is trigonal planar, right? So the angle is 120, so the principal axis is C3 and through 3 halogens 3 C2s will present like this. Each C2 is possible through one of the halogen and boron like this, right? So like that 3 C2s. Through 3 C2s, 3 sigma V's also present and one molecular plane is possible and the relation between principal axis and this molecular plane is perpendicular so that the molecular plane can be considered as sigma H. No I is present because N is R and the more examples are carbonate, nitrate because they have triangular planar structures. Borazole too. D4H point group. Order for this point group is 16 and the existing symmetry elements are E and 3 C4s. 4 C2s, 2 sigma V, 2 sigma D, I and S4 will present. When n greater than or equals to 4 and even, instead of n sigma D, n by 2 sigma V and n by 2 sigma D will possible. This is called thumb rule. For example, if we take the platinum tetrachloride molecule, it is a square planar molecule. So the angular is 90 degrees. So the principal axis is C4. Through two opposite ligands, one C2 is possible. Through these two opposite ligands, one C2 is possible. Middle of the ligands, one C2. Middle of these ligands, one C2. Like that, 4 C2s will possible. Through 4 C2s, 4 sigmas also possible. That means 4 plane of symmetry also possible. But here, these 4 planes can satisfy the rule of dihedral plane and the vertical plane. In these cases, what will happen is, the plane which is passing through more number of atoms can consider as a vertical plane and the plane which is passing through less number of atoms can consider as sigma D. So that in platinum tetrachloride, instead of n sigma D, n by 2 sigma V, n by 2 sigma V will possible. And one more example is trans-disubstituted octahedral geometry. Next, D5H point group. For D5H point group, order is 20 and E 4 C5s, 5 C2s, 5 sigma V, sigma H and remaining 4 S6 will present. So the example is cyclopentadienyl anion, right? So like this, the cyclopentane is having 5 corners, right? So the principal rotational axis is C5 and Through each corner, one C2 is possible. So that 5 corners are there. So that 5 C2s are possible. And through 5 C2s, 5 sigma V's also possible. So C5, 5 sigma V's and molecular plane can be considered as sigma H. And the eclipsed ferrocene also comes under D5H point group. D6H point group. Order for this point group is 24. The symmetry elements are E, 5C6, 6C2s, 3 sigma V, 3 sigma D, sigma H, I and 4S6. Here n is greater than equals to 4, right? So 6 is even. So instead of 6 sigma D's, so 3 sigma V, 3 sigma D's are possible, right? So the example is hexagon, that is benzene. Okay, in hexagon, the angle of rotation is 60. C6 will possible. The C6 is the principal axis. So 6 corners are there, right? Through 2 opposite corner, each C2 is possible. Like that, through 6 corners, 3 C2s will possible. Through 2 opposite edges, 3 C2s will possible. So that 1, 2, 3, 4, 5, 6 C2s will possible. Again, through 6 C2s, 6 plane of symmetry also possible. So according to thumb rule, the plane which is passing through more number of atoms can consider as sigma V. The plane which is passing through less number of atoms can consider as sigma D. And one more example for D6H point group is eclipsed dibenzene chromium. Next, D7H point group. For D7H point group, order is 28 and symmetry elements E, 6 C7s, 7 C2s, 7 sigma V's, sigma H and remaining 6 S7 will present. So, heptane in the sense 7 corners are there, right? So, C7 is the principal axis. Through 7 corners, each C2 is present. Okay. And through each C2, 1 sigma V is present. Like that, 7 C2s, 7 sigma V's. And the molecular plane can be considered as sigma H. Like that, in DNH point group, D3H, all trigonal planar molecules. Right? In D4H, all square planar molecules will come under. Right? In D5H, all pentagonal planar molecules. In D6H, hexagons. In D7H, heptagons. In D8H, octanes. So all planar molecules will come under DNH point group.